Hello guys, and welcome back to my YouTube channel. In our previous video we started the topic of count sort algorithm, and then we see how we can implement it, and then we start the coding count sort algorithm in C++. So let's continue our code. So now I will call the name set and pass the count one and then the size of our count. Now we will start our loops for I is equal to 0 and I plus plus. Expression preceding parentheses for parent call must have pointer to the function. Let's just figure it out. Yes. So now we are good to go. Now our second for loop. I is equal to 1 and I is less than or equal to the range. Now our third for loop for build the output character array. I is equal to 0 Now our last for loop for copy the output array to our ARR, so that ARR now contains sorted characters. For I is equal to 0 I and plus I. Now time for our main driver code. Now we'll pass that to our count sort function. And now we will see see out the sorted character array is so let's try to run our program and see if we have successfully achieved the implementation of count sort using C++. So yeah, you can see our sorted arrays sorted in an ascending order. So it was a successful execution of our counting sort algorithm. Now let's take a look at the time and space complexity of counting sort algorithm. So the time complexity is big of n, where n is the total number of element, and the space complexity is on. So the important points to note from this counting sort is efficient if the range of input data is not significantly greater than the number of objects to be sorted. Consider the situation where input sequence is between the range of 1 to 10k and the data is 10, 5, 10k and 5k. It is not a comparison based sorting algorithm. Its runtime complexity is big of n, with space proportional to the range of data. Counting sort is able to achieve this because we are making assumption about the data we are sorting. It is often used to subroutine to another sorting algorithm like the radix sort. Counting sort uses partial hashing. Counting sort uses the partial hashing to count the occurrence of data object on big O of 1. The counting sort can be extended to work for negative input also. Counting sort is not a stable algorithm, but it can be made stable with some code changes. So now we will see, if you remember, we have covered a video on insertion sort algorithm. Now I want to share how we can implement insertion sort algorithm using recursion. So the insertion sort is simple algorithm that works the way we sort playing card in our hands, as we have seen in our insertion sort video. And its algorithm is pretty simple. We have our insertion sort function, we pass it an array and the number, then it loop throughout the array and pick the element and insert it. For example, like this, it will go to every element one by one and will place the smallest element at the starting index of our array. So how we can implement it recursively. Now recursive insertion sort has no performance or implementation advantage, but can be good question to check one's understanding of insertion sort and recursion. If we take a closer look at insertion sort algorithm, we keep processed element sorted and insert new element one by one in the sorted array. So now we will look at some recursion ideas. Base case, if the size of if array size is 1 or smaller, then we will return and recursively sort first n-1 element and then insert last element at its correct position in sorted array. So now let's take a look at some coding example of implementing insertion sort using recursive methods. We will write our main recursive function for the insertion sort. Void insertion sort recursive. We will pass it our array which we want to be sorted, and then the size of array. Now we will check the base case. For the recursive function, you have to always define a base case to stop the recursion, otherwise it will keep on looping in the function. So our base case here will be if n is less than or equal to 1, then we want to stop our recursion and start returning the functions. Now sort first n minus 1 elements. Now time for our while loop. J is greater than or equal to 0 and jth index of array is greater than the last, until we want to this loop to keep going, and j plus 1 of array is equal to arr to the jth index and the decrement condition. Now our print array function. Now let's populate our main driver code. The main function, I will create an array of integer type and give it the values of 12, 11, 13, 5 and 6. And then the size of our array will be let's call our insertion sort recursive method and pass it our array and the length of our array, and then finally let's print our array. So you can see our array is sorted. So that's all from today's video. Thanks for watching.